Alright, so here are the last two of the planets, the real planets in our solar system, Uranus and Neptune. They're very blue planets. Neptune is bluer, a darker blue anyway, than Uranus for reasons we'll talk about. And these two pictures were pictures taken of the two planets by Voyager 2. And other than that, we don't really have such clear pictures. We have Hubble pictures, which, as you can see, can show some detail, but definitely aren't as clear. And you know, when Voyager took a picture of Uranus, it's kind of like, well, this is a pretty bland, boring planet. Where's all the bands and things that we saw on Jupiter and Saturn, and eventually saw on Neptune? You can see some bands and clouds, and even some big storms, like the great red spot on Jupiter. You got the big dark spot, which no longer is present on Neptune. But if you look at Uranus differently, you'll start to see some of those bands that aren't quite as evident. But very beautiful planets, quite a bit smaller than Jupiter and Saturn, but definitely bigger than Earth. Yeah, so. Oh, what's this? Let me pause. Alright, fixed. So, first thing is these two planets are really far away, very far away, and on the next slide I think I'm going to show you that in eyes in the solar system. Because they're so far away, we haven't really had much of a chance to explore them, even with spacecraft. Definitely can look at them in some detail with telescopes, Earth-based or even orbital-based telescopes, but in terms of spacecraft, we haven't sent many there, and we probably won't send many there in the near future because it takes so long to get there, and we got, currently with limited budget, other priorities. So it's kind of sad, but that's the way it goes. Also, because they're so far away, even though they've been around the entire age of the solar system, theoretically, we humans didn't know about them until quite recently. 'Almost the turn of the 1800s was when we first saw them. Even Galileo, when he first looked at the skies with a telescope and looked at the moon and Jupiter and found Jupiter's moons and all that, he he hadn't seen them. Although there's some evidence, possibly in his journal entries, that maybe he saw one of these, but don't know for sure. But anyway, it wasn't until 1781 that we first saw Uranus, so very recently in human history, and even much later, until we found Neptune. What was cool about Neptune was that as we studied Uranus, we realized it's not really orbiting the way we expect it to. So what's causing that? Is it just error in our measurement, or is there some other gravitational body that we don't know of that's perturbing it? And so eventually we made a mathematical model for what would have been affecting Uranus and plotted out where Neptune should have been. And when we looked there, lo and behold, bam, there it was. So that was a nice validation of our experimental process there and our theories of gravity and orbital mechanics. So just some properties of their orbits. And while I'm going through that, let me get eyes in the solar system ready. So just a quick rundown. Uranus's semi-major axis is 19.2 AU, or basically 19.2 times bigger than the Earth's orbit, because 1 AU is, as you can see here, the distance from the Earth to the Sun, so that's 1 AU right there. So you zoom out, and 19 of those on average makes up Uranus's orbit. Neptune is even farther out, 30 times the distance of Earth's orbit. So that's pretty amazing. They're really far out. It takes Uranus 83, almost 84 years to go around the Sun once, which is quite a long time. That's maybe about the average lifespan of humans in certain countries these days. So 1 year on Uranus is a nice long lifetime, one lifetime of a human. Whereas Neptune, on the other hand, no human has ever lived that long unless you're a Numenorian. Maybe Numenorian, that's a short lifespan. But the cool thing is, if you look back at when Neptune was discovered and you do the math, it's gone around basically just a little bit more than once in its orbit since we first discovered it. That's insane. They both rotate pretty quickly. Uh, Uranus's rotation is 17.2 hours. These, by the way, are not the orbital period of the surface that we see, like the top of the atmosphere. That actually, there's differential rotation there because they're gases in the atmosphere and they can rotate different rates. These were obtained using magnetic field data, which arguably would come from the internal structure, like a solid core maybe. Although as we're going to see, with some oddities here, that may not actually be the case. The magnetic fields may not stem from or originate from the solid rocky or icy cores of these planets. Yeah, strange things going on. But again, we know so little about them because they're so far away, and we haven't really been able to collect much good data on them. That got a lot to learn about them. Another strange thing is we're finding all these planets. It's not really strange, but it's just kind of ironic. We're finding all these planets, just hundreds, if not thousands, of planets nearby in our local galactic universe, I guess you could say. Yet we still know so little about our own planets. We use what we know. It's comparative planetology. We use what we know about our solar system and our planets, especially Earth, because we're right on it, to help us figure out what might be going on with the in the other planets. And so, you know, you'd, you'd think that we would maybe need to get a better handle on our own solar system before we can accurately describe other planets around other stars. But that shouldn't stop us from at least taking the data, collecting the data, and then maybe understanding it better as we understand our own planets better. So let's take and another interesting thing I'm going to show you on Eyes in the Solar System is Uranus's crazy axis of rotation, 98 degrees. Not only like if here's a planet, let's say this is the Earth, and it rotates around like this, maybe, and here's the North Pole, and here's the South Pole. This is, let's say, straight up is 0 degrees, and then as this line tilts, so if this line was like that, that might be like 45 degrees tilted down. 90 degrees would be if the planet is completely on its side, spinning, spinning like this, top to bottom. Uranus is 8 degrees beyond that. 90 plus 8 is 98. Goes down like that. I think there's a picture right here. Yeah. So straight up would be 0. This way would be 90. And so an extra 8 right here, this little piece. So Uranus's axis of rotation is tilted 98 degrees. This would be like the North Pole up here. That's yeah. How did that happen, huh? So let's take a look at that in eyes real quick. Oh, how did it happen? Some major theories in the past were that there's large impact, a large impact, or maybe even a couple or few that might have disturbed it. But strangely enough, the moons of Uranus also orbit in its new equatorial plane. As it's rotated around in this new axis, the moons kind of went with it, which you would think wouldn't happen in an impact. So maybe we don't really fully understand how the solar system formed. which is, you know, both frustrating and interesting and compelling because it leads us to look deeper into a problem, you know, and try to gather more data and clues as to how our solar system formed, which is pretty neat. So spend the last 4 or 5 minutes in eyes just looking at some of these things. So yeah, here's the inner solar system, the inner 4 planets, Mercury, Venus, Earth, Mars. There's us, yay! Zoom out, we got Jupiter and Saturn. Then we got the 2 outer planets, Uranus and Neptune. Let's look at Uranus real quick. Okay, where's the sun? Now, we're going to see something here. So there's the sun. Here's the plane of the solar system. Typically, planets would have an axis of rotation roughly straight up, or like ours is 23 or so, give or take some degrees, that way. So let's see, and I think we can see some light clouds here, so you can actually see the rotation. Yeah, see that? See it's rotating? So we're actually looking the wrong way. We're upside down, because this looks like it's less than 90. But if we flipped it like this, you ready? Whoa, whoa, whoa. There's the sun. Oops. Nope, wrong way. There we go. Um, well, I guess that's really no different. It's just a different. Actually, it's based on the side of the sun that Uranus is on right now. If we're on the other side, it would look different. But if you were to imagine a line going from here down to here, so I definitely dropped my mouse cursor right here. It was like up here, and instead of going straight across, I went down 8 degrees, and if you draw a line through the axis of rotation here, um, that's just strange. And look at the moons. These moons, anyway, the major moons of Uranus, also follow that. Strange. How'd that happen? Someone come up with a theory, please. It's cool moons. We're going to talk a little bit about the moons in the next video. Um, Uranus's moons aren't huge, but they're pretty cool. Yeah. So let's go out to Neptune. A little more normal in its axis of rotation. There it is. Oh, it's actually, before I do that, um, any pictures of the moons here, good close-up pictures, were taken by Voyager. Voyager kind of just did a flyby. It didn't orbit any of the moons. So if you use eyes in the solar system and you zoom in on a moon and you move around, you're like, what? Why is it so weird looking? What's this feature? Is it really that smooth? No, it's just that this is the only side that Voyager took a picture of. We don't have a good picture of the other side. That's how little data we have. Go to any of the moons and you'll see the same. Unreal. Whoa, they didn't even make that gray. That's just weird. Titania. Woo. So, yeah, don't be confused by that if you play around with eyes in the solar system. It's just, it's not a feature of moons way out far. It's just the fact that Voyager didn't see that side of the moon when it flew by. And Neptune, yay! Neptune's a different shade of blue. They got the great dark spot on there, even though it no longer is present. And you can see the axis of rotation isn't quite as strange, quite as intense for Neptune. I feel like I'm upside down. I don't know. Let's go back like this. Yeah, that looks better. Woo. Anyway, so let's look at the moons. There is one strange thing that you probably won't notice because I haven't really played with eyes in the solar system a lot. But and I don't see, where's the other, let's get the other moons going in here. Minor moons. Did that work? Yeah. Let's see here. What do you know? What's different about? Let me slow it down a little bit. What's different about Proteus and Triton? Do you notice it? They're going in opposite directions. What? We'll talk about a little bit more about that. But Triton actually has a strange orbit, and that's 15 minutes. So let's stop the video here. See you next time.